Hey y'all, welcome to part 2 of 4.4. We are going to look at some specific situations where we would want to solve exponential and logarithmic equations for real life problems. So we have a formula. Y sub t is the final amount. Y sub 0 is the initial amount, as in the initial amount at time equaling 0. E is our constant E. K is a growth or decay constant, and T is time. Okay? Now, if we have a situation where we are changing by a percentage, okay, if we are changing by a percentage, that formula is y sub t equaling y sub 0 times 1 plus or minus the rate, the percentage, times t, okay, where r is the percentage in decimal form. We'll need that one later. Now, remember that natural log and e undo each other, so the natural log of e to the x is simply x, and then log base b of b to a power is x. Logs and exponentials undo each other. So the half-life for a radioactive substance is the time it takes for half of the substance to decay or to disappear. Okay, half of it. So in example 1, we have a radioactive substance that has a half-life of 248 years. The amount remaining is modeled by this equation. How much of a 10-gram sample will remain after 150 years? That 10 grams is our initial y sub 0. That 150 is the t, the time. So to find that y value at that time, we do the original 10 grams times e to the negative 0.00279 times 150. So put that in the calculator. Um, 10 times e is second natural log, and it will automatically give you a power. Negative 0.00279 times 150. Just plugging that in, okay? Round that to 3 decimal places, so 6.580. 6.580. Yes, rounding to the nearest thousandth, we do need that 0. So 6.580 grams is how much remains after 150 years. So since 150 years is less than the half-life of 248, less than half of the substance has decayed, which means more than half of the substance is remaining. Then in the second question, it's asking us in how many years will there be 2.5 grams remaining. 2.5 is that y sub t, that final amount. And that time is what we're looking for. That initial is still 10 grams. So 2.5 equaling 10 times e to the negative 0.00279 t. So divide by the 10, and 0.25 equals e to the power of negative 0.00279 t. Our exponent is inside that, the variable is inside the exponent. We want to drop and cross to get it out. When we drop e, that becomes a natural log of 0.25 equaling negative 0.00279 t. And then to solve that, To solve that, we want to divide. We'll take natural log of 0.25. We'll divide that by that big value, negative 0.00279. And then we can put that in the calculator. So natural log, I'm just going to do this every time. Natural log of 0.25 divided by negative 0.00279. And we get 880. That 96 rounds up, so 880. So 496.880. 496.880 years is how long that will take. Now, in example 2, we have a little bit different situation. We have the bacteria in a certain culture, and it's tripling every 3 hours. So we have an initial count of 500. How long will it take to reach a count of 2,000? So when we are doubling or tripling, we have a little bit different situation. That y sub t equals y sub 0 times whatever that amount is doing. In this case, it's tripling. Every 3 hours, that's one time every 3 hours. So that's 1/3 t. One time every 3 hours. So that's 1/3 for that fraction. One time every 3 hours. So in this case, 2,000 equals 500 times 3 to the power of 1/3 t. Divide by the 500. So we get 4 equaling 3 to the power of 1/3 t. Now, 4 is not a base we handle easily. 3 is not a base that we can convert to. So we can put this in the calculator. y1 equals one side, 4. y2 equals the other side, 3 to the 1/3 t. And we can put that in the calculator. So in the calculator, going to y equals, clear anything there. Don't know why it keeps doing that. Really want it to be on 1. All right. y1 is 4. y2 is 3 to the power of 1/3 times x. I'm going to graph this on a standard window, zoom standard, and we'll start there. We can see the intersection, so we can make the calculator find that intersection. Second trace, 5 for intersect. On first curve, hit enter. On second curve, hit enter. For guess, move your arrow keys close to the intersection, then hit enter. When the calculator says intersection on the bottom of the screen, you're done. So 3.786. 3.786 is our solution. Okay, 3.786 hours. All right, let's look at example 3. We have a half-life problem. We have the equation. How much of the original sample would be needed to have 50 grams remaining in 25 years? It's asking us for y sub 0. Gave us that y sub t is 50 grams in a time of 25 years. So plugging that in, 50 equals y sub t times e to the power of negative 0.00173 times 25. Now, e to that power is a number. So we can divide by e to that power and put all that in the calculator. So y sub t will equal 50 over e to the power of negative 0.00173 times 25. And yes, we can do all of that. Yes, we can do all of that in the calculator at the same time. So, second quit to get out of that. We did 50 divided by e to the power of negative 0.00173 times 25. As long as that times 25 stays in the exponent, you're good. So 52.210. 52.210 is our solution. Yep. So we would need 52.210 grams originally to have exactly 50 grams left in 25 years. Number four is slightly different because we are changing, it's asking us to change by a percentage. So we have enrollment numbers at Pierce, the first day of school for the last 2 years. Yes, those are the actual numbers. Yes, I tracked those down. Yes, I had help doing it. So those are the real numbers, okay, on the very first day of school. So we're looking for a change by a percentage. So we use the y sub t equals y sub 0 times 1 plus or minus the percentage to the power of t. Now, that 1 plus or minus the percentage is how much we're changing by. So that y sub t is the second year, 2320, equaling 2427 times 1, in this case it's going to be decrease r, to the power of 1. So divide 2427. So we get 2320 divided by 2427. 2320 divided by 2427. Yep. Okay, so there's our value. Okay, 0.960. 0.956. 0.956. That 9 rounds up. So 0.956 is 1 minus r. So subtract the 1 and flip the sign. Okay, so take this number and subtract 1. So negative r is going to equal negative 0.044. So that r is 0.044. So what that means is it was a 4.4% decrease. To change from a decimal to a percentage, we scoot the decimal place over twice. Now, if this rate remains the same, how many students would be predicted in 27-28? Well, 27-28 is 4 years after the first value we have. We have 2023 numbers, so 4 years later. So we're looking for y sub t equaling that y0 is 2320 times 1 minus that percentage as a decimal raised to the 4th power. So putting all that in the calculator, $23.20 times 1 minus 0.044, close the parentheses, raise that to the power of 4. And we get 1937.847. That's the wrong number. That's the wrong number. Time out. My apologies. Our original is 2427 because that was the first year we had. We're looking at this year. We're looking at that year. So 2427 is our correct number. Shrink that down again. 2427 times 1 minus 0.044 raised to the power of 4. Now, these are people, these are students. We need to round this to the whole number. So 2027 is our number. So 2027 students in the year 2027. And that is a pure coincidence that I did not realize till I wrote this problem. But with those actual numbers and those actual percentages, that's what's going on. All right, another type of problem you may see involves being given an equation of a little bit different type. So something being thrown has a specific type of equation. In this case, an old couch is being thrown out of a second-story window. Do not try that. So equation modeling height in feet, t seconds after being thrown, is here. And how high, as in how high off the ground, is the couch 1.1 seconds after it's thrown? Well, height is negative 16 t squared plus 2.5 t plus 18. That t is 1.1. So plugging this in, negative 16 times 1.1 squared plus 2.5 times 1.1 plus 18. Will that look good? Yes. Enter. And 1.39. 1.39 is what we get. So this is 1.39 feet high. Then that second question asks, when will the couch be 9 feet above the ground? So 9 is that height, negative 16t squared plus 2.5t plus 18. So to do this, we can do y1, y2, and put those in the calculator. So going to y equals, clearing everything there, negative 16x squared plus 2.5x plus 18 is that equation. We're setting it equal to 9. I'm going to look at that on a standard graph, and we do have enough information to see this. So we have that parabola that represents the height, And we have that horizontal line that represents the 9 feet measurement. So what we want is the intersection. There's 2. Okay, this is an object falling in real time. So we need the positive intersection. Okay, so second trace, 5 for intersect. On first curve, hit enter. Second curve, hit enter. Arrow key across to the solution and hit enter on the guess. And when your calculator says intersection at the bottom, you're good. So 0.832. 0.832 is our answer. So in 8.32 seconds, the couch will be 9 feet off the ground. Now, if you need to see those calculator steps, I'll jot those down. You need Y1 and Y2. You're going to want to go to the graph. Okay, adjust the window if needed, meaning if you cannot see the intersection point, you will need to adjust typically your X max or your Y max in order to see the intersection there. Okay, then hit second trace, hit 5 for intersect. On first curve, hit enter. On second curve, hit enter. On guess, move the arrow keys. Move to the solution you're trying to find, then hit enter. If you do not move the cursor yourself, it will find the one closest to you, which may not be the one you want. All right, that's it for 4.4.